Hello, my name is Xenophon Papadimitris. I'm a professor in radiology and biomedical imaging and biomedical engineering at Yale. This interview is part of a collection of conversations with experts in medical software from academia, industry, and regulatory agencies, and is supplementary material for a Coursera class Introduction to Medical Software that will appear in the fall of 2021. Our guest today is Saradwata Sarkar. Dr. Sarkar has a PhD in biomedical engineering, has been working in the medical device industry for more than a decade. He has led the development of multiple medical devices from ideation to regulatory clearance and successful deployment in the market. Dr. Sarkar's career spans various technology solutions, including cancer diagnostics and digital dentistry, and he's regularly invited to share his experience at various professional meetings around the world. And he and I have worked closely together in the past on joint projects. So what I was hoping we'd talk about today, in some ways, at least that's the first part, is as somebody who left university, went to the medical device industry, I want to talk a little bit about what that transition was like. What was the change from graduating and moving to industry? What did you wish what you knew? What was strange? Think about it as advice to students who leave a university and go to industry. How do we prepare them for that transition?
Okay. All right. So firstly, thank you, Xenios, for inviting me over. It's always a pleasure to talk to you. And so interesting question. I actually still vividly remember this. So once I graduated from like finished my PhD up, I joined a company in California, and I walked in the first day all ready to impress. I was ready to write as many lines of code as they needed me to write. I was all ready to go, all ready to impress. And so imagine my surprise. Instead of getting even one single piece of code to write, what I got was one thick binder full of SOPs, standard operating procedures. I opened them up, tried to read them. They were completely esoteric. I didn't understand like one single word of what was written in them or why we even needed to do this. I felt all at sea. so that's my first day at work, and it took me a few weeks before I could grasp that how different academia was and the approach to work there was as opposed to software development in the industry. And I think that for me was the biggest shock. And yeah, if there's one advice I could give students was sort of to, if you're preparing for a career in the industry, definitely don't go in like how I did at the beginning, but just like sort of have an idea of what happens. And in terms of what happens, I think the biggest thing to understand is that every serious software development that is done in the medical device industry happens under the umbrella of a quality management system. So there's a QMS to follow, there are standards to follow, there are procedures to follow. It's not about sitting and writing a piece of code in front of the computer. That probably does work out in academia because the scope is different, but that's not how it is definitely in the industry. And definitely like a lot of the serious work that happens for developing any software program or medical software device happens even without writing a single piece of code. A lot of it happens sort of behind the scenes, trying to understand what the user requirements are and all that.
So let's delve into that a little bit more. So informally, we describe the sort of programming that happens at universities as using a code and fix lifecycle. You code, you try it breaks, you fix it. But that's not how a formal software lifecycle would work, especially a device that has more than a minor level of risk associated with it. So can you just talk a little bit about the software lifecycle process? What are the steps? What advice do you have to share here?
Yeah, so I mean, the software, from a software lifecycle perspective, the standard that you would look at is the IEC 62304, and that's what you would sort of take into account, and that's what lifecycle processes would be based out of. But just in terms of understanding how to go about developing a piece of software, it's a little bit beyond the coding and the fixing that you talked about. It's more about really figuring out from even before you start to code, figuring out what the user requirements are, really nailing them down, then sort of cascading those user requirements into software requirements and the specifications, and then sort of designing your software around it, designing the architecture of the software around it. So there's that entire life cycle of doing that, and then you do the development, and then each of these has a risk management step associated with it, and then finally you release it and deploy it into the market. So there are a lot of steps involved there. It's definitely not about just coding fixing. Those set of cycles are definitely absent in the industry. Yeah.
So when you look at the standard, it looks like what one in a software engineering community would call a waterfall cycle. One way through, you do this and you do this and you do the next. That's not always how it's done in the real world. And we've talked a little bit offline before about agile processes and sort of more iterative approaches. If you can just elaborate a little bit more for students who haven't been exposed to that.
Yeah, absolutely. So the waterfall cycle is what I call an idealized model. I mean, it sort of makes in an ideal world that would be great if you understand all the user requirements at the beginning, and then sort of all the processes flow from there on, like a waterfall, like a cascade of waterfall. But that's not how it kind of usually works in real life. From what we've seen, we usually have moving goalposts in a real life situation, where you have like a lot of iterations, where you are continuously doing releases, usable releases. And that's where sort of the agile framework comes into the picture, where you have like a lot of iterative cyclic loops through the entire process, and not sort of the linear waterfall kind of a process that we usually talk about ideally. So definitely, I mean, agile is what I'm seeing here, mostly used in practice.
So if we go back to some device that you have developed, that say the development process took a number of years, how many cycles, how many interim releases would you think have been?
It's difficult to put down a number, because then there are sort of releases, and then there are incremental releases, and quite a few of that. So I would say, in terms of easily a software product that we would have developed in our team, that would have taken 2 years to develop, we would have had easily like 2 major releases perhaps in that. But then it's easy to see like maybe 2 incremental releases even within that subset within that. So that's completely normal to have that many, and sort of agile, I think, makes that more possible, to have that sort of a go out to the customers. That way you're not sitting at the end of 2 years, and then you have something, and maybe then you figure out that that's not what you were trying to develop in the first place. So yeah.
Mm-hmm. So you're thinking, you're essentially looking at, you've been through the life cycle 4 or 5 times by the end time you get to the end, right?
Absolutely. Yeah. Absolutely. Yeah.
Okay. The other part that, when we were planning this yesterday, we had talked about was this whole concept of the voice of the customer. I tell students, and I don't think this is unique to me, that programming is easy at some level. Figuring out what to program is the hard part. So let's talk a little bit about, how do you understand what your customer needs? In a medical world, you're building something for somebody. You're not telling them to discover something they know they need it. That's not how it works. You're building to satisfy some need. But how do you understand what that need is? It's often vague. Solve my problem is the best you're going to hear. But so let's hear a little bit more about your experience with this process.
Yeah, Xenius, that is a tough problem, but it's very, very important to get that down, as you correctly said. So voice of the customer. So it's important to understand that for the software, it's the voice of the customer that's not important, that's important, and not the voice of the engineer, which is what often happens if you don't completely understand sort of your user needs, right? And actually, unfortunately, there's no real substitute to interacting with your customers directly. I mean, if you can, and if you have the opportunity as a software developer to do that, please go ahead and do that, and try to understand directly from your customer what their needs are, what their pain points are. The more varied you can sort of get your customer base, like for example, suppose you're targeting like a medical practice, perhaps go into the academic medical practice as well as the community medical practice. Try to get a good sampling, like a sort of a distribution of your users, understand what their pain points are, and they're going to be different. They're going to be different in different settings. Understand what the user personas are, is what we call it, because most often when you're developing a software, sometimes, let's suppose this medical software, sometimes you think this is like, okay, the doctors and the nurses are my customers, and that's mostly true. But what's also there is perhaps this hospital's IT department is also your customer. The hospital's administration that will allow this software to be deployed there, that's also your customer. And that's simply because they might have their IT might have their own cybersecurity requirements. The hospital administration might want your software to talk to the EMR. You need to understand the entire clinical workflow, and that's when you start developing your product. So your product need not just satisfy sort of the functional requirements of, sort of like maybe a cancer diagnostic product, or whether this is cancer or not, but everything around it that will make the whole clinical workflow work.
Yeah, so sometimes the challenge is that what you think your user is not necessarily all that your user is, right? There are more, even a doctor that doesn't use your software may use the output of your software and their needs. And so how do you identify who all these people are? It seems like a puzzle here. Right?
It's a bit of a puzzle, and there are multiple ways to do this. I mean, one of this is, of course, direct customer interaction. I mean, you visit hospitals, something, if that's where your end customers lie, you try to understand what would get your software installed there, and typically you before you even get to the layer where you're talking to the doctors or your nurses or whoever is going to use your end product, you're going to talk to the hospital administration, you're going to talk to the hospital IT, you're going to figure out a lot of those sort of places that are going to decide whether your software is going to ultimately get installed. And that's kind of it. So basically, you have to do your focus group surveys. You have to talk directly to your customers and figure out what the needs are. It's not an easy process, but it's a process that needs to be done anyway.
So do you have advice for people when they're starting out about visiting hospitals? Now, if you've never left an engineering department, a hospital is a very different place, right? So what are some of the issues that one encounters as you walk into this universe?
So in terms of the hospital, for one thing, my experience going in there was it's you have to have certain certain tests or something that you've done. Like for example, most hospitals won't even let you in if you don't have, like, say, for example, proper vaccinations or something. So there were all these lots of paperwork that needed to be done. There were HIPAA processes that you needed to be trained on. So there were a lot of these training procedures that needed to be done and that needed to be completed before you can even get into the hospital and understand where you are at.
Okay. You used the word persona at some point as you were describing the users. Can you elaborate on what a persona is? Can you just flesh it out for us? So think of an imaginary user. What does that persona might look like? Yeah.
So user personas are basically the stakeholders that are going to use your product. So for example, suppose you've developed this cancer diagnostic software, right? That cancer diagnostic software is probably going to be, let's say, used by the radiologist, who's going to use that, interact with that directly. And maybe the output of your software is, this is cancer, this is not cancer, right? So that's your main user. Radiologist is your main user there. But then in order for the radiology software to work, that needs to perhaps talk to the hospital's PACS system. And that's probably where the IT of the radiology department comes into the picture. Your software needs to be able to communicate with the PACS system, and in order to sort of download images or input or output images. And that IT department becomes your next customer. They may again have cybersecurity requirements surrounding that. So those are an entirely different set of requirements than just the core functionality of your software, which is to say whether it's cancer or not. And so this is how you build on the user persona. So what I'm trying to say is, you need to understand this entire clinical workflow. It's not about just the sort of the end user that's using the software, but the entire clinical workflow of the software as to how would this be installed within this clinical health system that you're planning, and how would it be used from start to finish.
Often when we develop these things, we have a key user in mind, our main collaborator, who of course has particular needs which may not reflect the needs of the community as a whole, right? They are at the high-end academic center often, they are often experts, their needs may not reflect. So one of the dangers is that you over-design for that, right? They are the most visible, your most vocal user. The person who talks to you a lot, which means that they get their input in. How do you sort of separate the general needs? How do you not overlearn effectively, to use a machine learning term, from your main users for the needs of the population of users as a whole here?
Yeah, and that's a very important point, and that's what I come back to say that it's a very important that you actually get a good sampling of customers when you're trying to form your user needs. It's not about going out and talking to that one KOL in your field who might have completely different needs or completely different thought process regarding the field. Typically, when you talk to KOLs, they are more perhaps receptive towards high-end software and high-end features that your software may have. Perhaps this cancer diagnostic product needs to be able to talk to your mobile phone at the same time, and maybe that's important to this KOL. But from the community perspective, maybe their most important uh, point is that it needs to be easy to use and needs to be really quick and needs to be cheap. So what I'm just saying is that they're completely different needs based on what section of or customer that you go to talk to, and so that's why it's very important. Get a good sampling, talk to multiple customers from different sort of locations, and then you'll get a very good understanding of what the needs need to be.
So what you're saying here is that my user is not a radiologist, but it may be a group of radiologists at different ability levels and settings. And while you think, well, a radiologist uses my software to diagnose cancer, the 4 radiologists at the 4 different settings, they have completely different needs, and probably you should think of them as
absolutely, and completely different trainings as well. And some of them, perhaps in academia might have been dealing with hundreds and thousands of images, and perhaps have a different level of experience dealing with those kind of images. And that's where you have to target the usability of your software as well to sort of cater to the different users.
As an aside, for the students, use the expression KOL. That's key opinion leader. That's sort of a high-end practitioner here. The other thing I was going to talk to you, Sarad, is this is part of the planning we did yesterday. There are obviously the functional requirements of a software, right? It has to, in order to satisfy my user's need, it has to do this, A, B, C, right? These are the obvious things. The users will tell you what they need. They may tell you in vague terms, you have to translate them, but they will tell you. But then often what makes or breaks software is not the things that they tell you, but the things they don't tell you, right?
Oh yeah.
So let's talk a little bit about that process. What I would term, when in my slides I use the word non-functional requirements. There are other terms here, but let's talk a little bit about that, because that often is make or break for software.
It is, and to sort of quote a non-medical example, suppose you're building a car. You go to your user to find out, hey, what does this car need to have? What would really make you buy it? The user might tell you, oh, it needs to accelerate really quickly, and it needs to do this, do that. They're probably not going to tell you the car needs to go in reverse, right? Nobody's going to tell you that. It's obvious. So that's what I'm talking about. So it's very important to talk to your customers, but also to understand the limitations of what talking to customers and users is going to get you. Talking to customers is very good to figure out what their current sort of pain points are in their system of what they're using, or what would really excite them. What are features that they would love to have but they don't have? Those are the kind of things that it's very good to talk to customers about. Then there are other things, like which is the basic and the given things in the system. Like, for example, the car going in reverse, for a non-medical example, the car needs to go in reverse. And that's something that you have to find out on your own. You need to study perhaps competitor systems. You need to study, focus groups or do interviews or something, and just basically figure out from there what are the basic functionalities that need to be within your software. I think Xenios, when we were talking, you gave an example of left is right and right is left in radiology or something, right? So that's again basic. I mean, nobody's going to tell you that you need to be able to know that, and so those are the basics of the system, and those are all important needs, without any of which you're either not going to be able to sell your software because it's too similar to somebody else, or is not going to meet basic requirements. Then there are also other requirements where actually, if you have to understand some things that the user perhaps doesn't want you to make, which you might make, which might make logical sense to you, and that might become like have a reverse effect on them using the software. And I've had previously personal experience with that, where there was this annoying pop-up that one of our softwares used to have, which probably made logical sense from an engineering point of view to warn the user, but perhaps for the user it was really slowing them down. And again, there was probably a better way to convey that message to the user without having them to interact with the dialogue all the time. So that's sort of a feature where you put something in extra which is actually annoying to the user. So that's again something to think about. That's a need that you don't want to meet. So again, so those are all different categories that are that you need to take into account.
Is there, I mean, I think we've gone through the list we had here. Is there anything else that we didn't talk about that you'd like to bring up at this point, or any more specific advice you want to give to people as they embark on this journey, or anything else you'd like to add?
I think, Xenios, we've covered all the important points. All I would basically say to anybody looking for a career in the industry is, academic life definitely prepares you well to do all the technical stuff, and that's really important. That's not to be underestimated. And but definitely, it makes sense if you're planning a career in the industry to build on that and to sort of understand a little bit before going in what are the different sort of processes that are followed in the industry, and they're fairly finite set of processes and standards that are followed. So it's not that you're sitting on something that's impossible to understand, but just to get a basic understanding of that is definitely helpful, I feel, in the transition going from academia to industry.
Okay, Sarat, thank you for joining us.
Right. Thank you, Xenios. Always a pleasure to talk to you.